We are ready.
Okay. So good afternoon, everyone, and welcome to our third session. Yes. So with the third session, we are basically picking up from where we ended on our second session. And just a quick recap of our second session, we were looking at how we were saving and handling DLRs. When you can see my screen, let me know, and then we begin.
Yeah, you can see it.
Okay. So just to give you, so the last session, we looked at the code. I was performing that. So before we go back into the code, I just want to draw the visual representation of what we discussed. So we're going to call this Nano server or the, yeah. So let's call this the prod server, right? Great. So once emails are sent out, we receive the notifications from Amazon Simple Notification Services. So this will be all notifs from SMS. Okay. So with the endpoint we provided to the SNS, all of them just hit our backend API like that. I think I mentioned if it's possible, take a look at how the data is coming. I don't know if you guys were able to take a look at the data coming in. So yeah, all this hits our endpoint on our prod server, which is the, well, on our messaging platform. Yeah. Okay. So this is a representation of what we went through on our last session. So nothing should be kind of new here. Yeah. So once it hits this, right, we save everything. Basically, we funnel everything into a file that we call email DLR dot, I think, txt. So email DLR dot txt. So yeah. And then we have our scheduler, right? We have our scheduler here. And our scheduler runs a task every minute to check if there is data in this file, right? So our scheduler actually runs several tasks. It runs, it runs scheduled messages and all of that. So think of it as a crawl, yeah. So we have a scheduler that runs every 1 minute to check email DLR. And if there's data in here and the scheduler picks it, so the scheduler picks the email DLR. So the scheduler picks this and then it splits it into several different other TXTs. Yeah. Okay. And we rename it into this timestamp 1, timestamp 2, basically timestamp n plus 1. Yeah. So let me do this. It could be n plus 1, more or less. Yeah. It saves it into these various files. And We have them in there. Yeah. So the scheduler runs every minute. It picks these files. It splits the email DLR because as we discussed last time, for a blast like 500,000, we can get as much as 1.5 million notifications. Yeah, you can get as much as 1.5 million notifications. So once it hits the messaging platform, we dump all the DLRs into email DLR.txt. We have a scheduler, it picks this up and it breaks it down to bite-sized chunks. So think of it as a mother bird or a lion breaking the food down for the cubs to eat. Yes, more or less. So this same scheduler has another task that will then proceed to pick these bite-sized files. And then this is when it proceeds to save them in the DB. So this is basically what we discussed the last discussion we had. I think we saw where this was happening. We saw where this was happening. We saw the scheduler pick this, split it into 200 pieces each. Yes. So these files are 200 DLRs each. And yeah. So we saw the code for this, and this. So today, I'm going to talk about what happens when the little cub or the little we decide to read one of these individual files. So before I proceed, does this make sense? Do you remember? And yeah, I would like a confirmation, a verbal confirmation before I proceed. So yeah. Okay. Okay.
One more question before we move to the next stage. On a request to the DLR server, like how many notifications do you have it on one call, or just one, or
how many?
Like when we see the callback, right?
Yeah.
From the SNS, right? Each callback, like how many notifications? Is it just single or it comes in bulk?
Oh, single. Because we are calling. So because we are calling singularly, it also returns singularly. So every message that hits this, every message that comes from here to here, that's, if I'm correct, Alex, you are talking about this line, right?
Exactly.
Yes. So this line contains the data for one.
Okay.
It's per one. Yeah.
Okay. So if I'm wrong, please correct me. So you are saying that the callback it comes like 10,000 in a second, right?
It comes back per how much we push to it, right? And initially, it returns, usually, once we push, in about a second or two, we get sent, the sent callback.
Okay.
The successfully sent callback in about a second or two. So if we are pushing roughly, I think the last time, I think it was 16 threads. We have 16 threads spun up. And in the second, it says about 2 or 3. So 16 times 3 to 18. So let's say 50 per. So currently we are sending out 50 per second. And this is taking, let's say, this is if it's only one blast that's going on. If it's multiple plots, that can increase. But currently it's 50 per second. But from what I remember from my time, it's pretty fast. Like if you look at the logs whilst it's happening, you wouldn't even have time to read the logs. So I would say 10,000 per second here is kind of pretty high, but it tracked 1,500. 1,005, 2,000 per second. Yeah, I remember we were kind of hitting that some time back. Yeah. And also the other reason we are able to hit that is for each line that comes, for each message we send, right? We receive at least two notifications.
Okay.
And those two notifications can be concurrent, actually. I think maybe a second apart or 2 seconds apart or something like that. I think the first one is would be similar to SMS's ACK, right? Then the sent will be similar to SMS sent. Yes.
Okay. I get it.
Yes. Yeah. Then the corresponding ones is what the user does with the email. Yeah.
Okay. All right. Without continue.
Any more questions before I continue? Whilst we look at what happens here. Okay. So the reason for this scheduler and this issue and all of this is when we look into our database, let me try to find this. Great. Great. When we look into our database, sorry, let me find the right model. This is the DLR class. That's not what I want, actually. I want email backend models. Yes, great. This one. Yes. So, as I mentioned a while back, I think during our first meeting or second meeting, when we fire emails from our system to Amazon system, we are basically firing one email. So for 10,000 emails, you are making 10,000 unique calls. So for those 10,000 unique calls, we would get 10,000 unique IDs, right? So the job is, let's say, Happy New Year from Nalo. So Happy New Year is the bulk email. So we are sending to, let's say, our 100,000 clients. So the 100,000 clients emails we sent out, each of those 100,000 has a unique ID. And we need to be able to track each unique ID and what's happening to each unique email. So we need to track what's happening to each unique email and also track what's happening to the whole email job as a whole. So in relation to that is how we came up with the structure for the email. So for now, 3 tables or 3 models are our major concern. One model is called the email job. The other one is called the email log. And the last one is called email job stats, where stats stands for statistic. For the email job, I don't even know if I should talk about it, considering you already know what it is, but let me just touch on it a little bit. For the email job basically defines the main job. By the main job, the number of people you are sending to, the time you created a message, the content of that message, and everything. So the email job is like, that's the job itself. Then the email log are the individual unique email addresses that come together to do the email job. So let's say for a blast of 100,000 emails, we would have one email job, right? And this one email job will contain details like, in fact, I have it here. So it will contain details like which user created a job, the job's unique ID, the sender email, that's who is sending the email, sender name, the subject, the status of the job, the emails, all the emails which is going to. So if it's 100,000 emails, we will find all 100,000 emails here, the 2. Then failed emails. Failed emails would be basically the ones that are blacklisted, or I don't know if you put duplicates inside failed emails or all, but yeah. Then we have message, which is the body of the email, because I mean, it's the same email that's going to everyone, so it doesn't make sense you save it individually. Then we have the pricing here, then sent by, and the channel it was sent through. So that's what will be in email job. And the next part would be, so a blast of 100,000, we would have one email job and 100,000 email log entries. For the email log entry, the email log entry basically is for each individual email to each individual client. Sorry. So we have the user, whoever created an email job. We have the email job itself. We have the email ID, which is a unique ID specific to that email. We have the status of the email, which the status of the emails, which are pending, sent, rejected, delivered, blah, blah, blah. Then we have external ID. Okay, we have message here. Why do we have message here? I think for custom messages. I don't think we save it for everybody. We have external ID, where external ID is one, the ID Amazon is given to us, or whichever third party we are using is given to us. So that's the external ID. And we have the response. So the response is also the JSON response we are getting from the third party, be it Amazon, MailChimp, Mailgun, whichever. So that is the full body of the response. Then callback response, callback response. I don't remember what this does, but oh, callback response, yes. So callback response is for notifications. Like, so at this point where we format an email and then we hit Amazon SAS, we get a response. Then when Amazon SNS sends an acknowledgement, that's the callback, we also save, if I remember correctly, I think we save the data here or not. That's what this callback response looks like. I'm not sure if we are using it or not. Yeah. So for a blast of 100,000, we create one email job entry, 100,000 email log entries. And then finally, we create one, I think, email job stats entry. The email job stats is where we base most of our reporting on. So if you go to email job stats, you can see total emails pending, sent, rejected, delivered, all of that. So what happens in this table, email job stats, is basically running a query here that says some group where basically we are finding the number of emails that are pending, that are sent, all of that, and we are saving it here. So that if you want the statistics, we don't need to hit all these 100,000 rows. We are hitting just a single row over here. So these are the main models we use in sending out the email, using it for reporting, and handling external information. Before I proceed from here, do we get this? Or any questions? Okay.
We get it.
All right. So those are the models you have played with. So now we come back here. Let me just drag this here. So we have the scheduler that gets this file, which can be 10,000, 100,000, or maybe 5,000. And it splits it into 200, 200, 200, 200 each. So what it does is when the scheduler runs and it splits this, we create a timestamp _n or n+1, basically, to be able to know which files we should process first. Yes. So we have another task in the scheduler, that picks up these tiny files and then saves them in the database. Once it saves them in the database, that same job will then proceed. So let's say it's currently, what's the time currently? 1:24, right? 1:24. So this scheduler will run again at 1:25. And then it's run again at 1:26 because we've spaced it out minutes per minute. Great. So let me get the actual name for the job. It's called Save DLR to DB. So the name of the task itself is called Save DLR to DB, and it runs every minute. So we have this running this minute, we have this running this minute, and we have this running this minute. So if it's all good and Jesus loves us, this will run every minute. And when it runs every minute, what it does is, one, updates all email log based on file, right? And we know what email log is per email. And then once you finish updating that, then it will update email job stats based off DLR save. So it will pick this file first, save the contents in this file, update email logs. Once it's finished updating email logs, it will then come and update email job stats. So if you are looking at it from the front end, you will see your map, your pie chart kind of updates every minute. So every minute, I pick this file, updates every minute, we do that. And that's how the Save DLR to DB works. There are a couple of caveats though. If there's heavy load on the server, if there's heavy load, good. If there's heavy load on the server, well, not heavy load on the server, if it's processing lots of tasks, by the time this minute comes, right? What's going to happen is at 1:24. So let's say I've run into situations where we have, I would say, probably 500 or 350, or I remember we even had 1,000 a couple of times of these 200 files over there. So let me use, let's say we have 500. So we are processing these 500. Remember, we are using timestamp _1_n. And we already have a scheduler that's going to pick this. We have a scheduler that will pick this and split it into this. So that means every minute, this number of tiny files, let me call them baby files. Let me find the baby pip. Let me call these baby files. They will increase every minute because this scheduler will go and read this and split it into more baby files. Then we have Save DLR to DB, which is also working every minute, picking these up. We are using timestamp because what we are doing is we are sorting it and picking by first come, first serve. Yeah, I can order by time created, but what's the point if I can save the name by time created? So we are using time created. So we are using the name and then we are picking. So if this is running at 1:24, right? And 1:25 comes, 1:24 will not be done with these files, but because we are sorting by name, 1:25 will come and also pick the same name of the files. And if it doesn't finish, 1:26 will come and also pick the same name of the files, you see? So to prevent that and to prevent double work, there is a condition in this task where 1:24 starts. Before it starts at 1:24, it checks, is it already running? If it's not running, then we execute at 1:24. So the next minute comes, we check, is it running? If it's running, we don't do anything. At 1:26, we check, is it still running? If it's running, we don't do anything. However, if it stopped running at 1:26, then we pick it up. Once this task finishes saving, what it does, it deletes the files it's done with. So at 124, it's working. At 125, we call this, we realize it's still working. At 126, it's done with. So by the time this is done with, it will delete this file and this file. Basically, the files is working with, and this task will pick the next file in a chronological order and then continue working with them. If we didn't put that check in, what will happen is on this command, we pick file 1, 2. When this one comes, this will also pick file 1 and 2, right? And that's just, I mean, it's just work that we don't want to be done. So if this is running, it will not run again until it's done. That, however, is an issue here, and it's one of the debugging things you should be aware of. If probably DLLs are not updating, what might have happened are there may be a couple of issues here. Sorry. There may be a couple of issues here. So let's say the save DLL to DB handles 2 files at a time. So if _1, let me make it _n. So if _n plus 1 is not done, save DLL to DB cannot work on _n plus 2 and _n plus 3. Save DLL to DB works in this order. So that means if there's an error in this file, and there's also an error in this file, what's unfortunately going to happen is save DLL to DB. I think I fixed it. If you go to the code, I'll check, but I think I fixed it. Save DLL to DB will keep trying this over and over again, and kind of ignore this until these two clears themselves. I don't know if I dealt with it or it's still there, but when we get into the code, we would see what's happening. So that means save DLL to DB can run, finish running, but because these files are not clear, they are kind of it will become like a queue because stubborn proud is deciding it's not finishing. So ways I was handling this was if I see DLLs are not updating, I just look at the names of the file. If the file names are not clearing up after a minute, I just rename the files to probably 99999 or something, so that this n and this n plus 1 can move out of the way and these files can continue to process. Should I go over that again, or you understand, or you get it? This is just in case if email DLLs are not updated. This is one of the possible causes.
Yeah, I think we had similar issue with SMS, if I'm not mistaken, right? Yeah. So yeah, it's well active, but I think we still have to dig deep a little bit to see how best we can make this thing.
Process, yeah, of course.
Yeah. So
yeah, of course.
Yeah, it's well active. I think the issue is going to be.
Okay. Then another possible issue that might cause DLL to fail are, sorry, Celery has crashed, or for some reason something has happened, it missed something. However, remember, we started this task at 124, and we mentioned that before the task run, it checks to see if it's already ready. The way we do that is we have a flag in our Redis cache, and it checks that flag to see if the flag is true or false, right? So based on the condition of that flag, it will proceed. However, if Celery fails or something like that, what's going to happen is that flag is going to still say, I am running, right? Meanwhile, it's not running. I hope you get me.
Yeah.
So because of that, anytime Save DLL tries to work, it will see the flag that says, I am still running, even though it's not running. and then it will fail to run. So one way you can do that is you can look at the Celery logs, right? And if for more than 5 minutes or for more than 4 minutes, it's still saying that it's kind of busy, it's giving a response of, I'll show you the response. If given that response, then what you do is access the Redis cache and just delete that entry. So once you delete that entry, it will pick up again. Yeah.
Okay.
Because that flag is capable of blocking consequent ones. And I mean, you cannot wait for 1 hour for that to end. So let me show you those items. So this is I call it a DLL processing flag. So that shows the DLL is working or not. And in cache is called saving email DLL. So over here, if it exists, I'm getting it doesn't exist, I'm setting it to false. So if it's false, that means nothing is running. However, if it's true, that means a task is running, right? Sorry. Sorry. So when you look in the Celery results, if it's successful, you would see it will tell you X number of jobs updated with a duration, right?
Yeah.
Even if there are no DLLs to update, it will say 0 jobs updated. It will literally say 0 jobs updated if you look in the Celery, the reports of the Celery. So if you see 0 jobs updated, it's fine. It's okay. That means there's no DLLs. However, if you see save email DLL to DB process already running for 5 or 6 times, then something might be happening. And then you are free to reset this flag to false, or you can delete it from the cache entirely to reset the DLL saving process.
Okay. Okay.
So yeah.
All right.
Okay. So now we are going to look at the code that actually handles this. So one thing, the scheduler that handles this files, it handles 100 files at a time. Yeah. So right here, it picks the first 100 and it handles it 100 files at a time. So this should let you know that they can quite grow. The number of files, they kind of grow. Yeah. So it picks one file and then we go in here. So this is just for timing the time it took to process. Then I'm reading the file over here. So inside the file, each file contains 200 unique DLLs. So for this 100,000 email job, we'll find 200 of the DLLs in each of the baby files here. So we handle it line by line. And what we are doing here, by me saying handling it line by line, is for each line, we are determining if so this was already done in the previous. Okay, let me just go back. So I'm going back to here. When Amazon hits our messaging platform. So when Amazon hits our messaging platform, whether it's Amazon or what's it called, Mailgun or whichever, we have what we basically do is we check if the structure is the structure we are aware of. Because it's from Amazon, we are aware of Amazon structure, we know what to expect. It's from Mailgun, we know the structure, we know what to expect. And then we confirm that if it's in the right format, we strip it into something we can use. And this is what we want to use. We want to use something called, we want to use it in this manner, status and message ID. So status will change the status from third-party specific status to back-end to email specific status. So if this is Amazon's own, so Amazon is sent, it looks like ours is sent, we make it sent. It's either this to this or this to this, I've forgotten. But we change it from Amazon specific reference, Mailgun specific reference, MailChimp specific reference to Nalo specific reference. And then MID, which is message ID, is the external ID. So whether it comes from MailChimp, whether it comes from anywhere, so that's why this is called Save Amazon Email DLR. So this handles just Amazon's own, because what we want is we want to get this, the output in this structure, so that no matter the third party it comes from, we can kind of work on it. So we put a status in the way we want it to be, and then the external ID. And if you remember correctly, in this table, email log, we are saving the external ID for each individual email. Yeah, so that's where this is happening. So if we access this file, this email DLR.txt, you'll find maybe 500,000 lines that look like this, where the status will be something like maybe sent, and with a message ID of something like this. Yeah. And that's what would be in there. If the message we are getting from Amazon or whatever does not correspond to what we want, we save it in undefined status.txt. I went over this the last meeting. Yeah. Okay. So because we've already formatted our data, we kind of know what to expect here. We kind of know what to expect here. But for shaggy reasons, anything can happen. We also have an exception built in here, right? And if there's an exception, we just skip that line and we continue with our processing. So we know that this is the data. Where are you? So we know that this is the data in the DLRs. We know that there's the data in the DLRs. We have the status and we have the message ID. So what we do in this loop is we build a really long ass query where we know the status, we know the message ID. So what we are building is we are building update what's the name of that table? Email log. So we are building update email log, right? Set status to this status sent, where external ID is equal to the external ID we have over here, right? However, since we know there is a precise number of, what's it called? There's a precise number of different statuses. So what we do here is, so for the 200, remember this code, we are talking about this, was handling this little one over here. So that's 200 each. So the 200 each are kind of grouped under their individual statuses. And this query basically build, so where external ID would be external ID type 1, or external ID 2, or external ID 3. So this would happen for each individual status. So we have the sent status, we may have the pending status, we may have the open status, and that's what this loop does. So at the end of this loop, we would come up with probably 1 query, 2 queries, or 3 queries, depending on the number of statuses available in this file. So if this file has only delivered statuses, then it will just be 1 query. However, if it has delivered, sent, and blocked, it will be 3 queries, of which we would use to update. So over here, all we are doing is we are building the specific. So if you look at this carefully, it is it's a Django module code, and we are building it. So once we are done building it, right, we actually proceed to saving it. So this is where we actually save it. So what we do over here is compile the allowed keys. So compile the allowed keys, the individual keys with the individual statuses. And then, so for each status, we get the actual ID for the status, email log using workers, filter. So we filter this. So this is us executing the code, and then we update it. This result actually gives us the number, and it's very important. It gives us the number of lines that were updated. By the number of lines that were updated, the number of rows that were successfully updated. So if it's, because we are using OR, we need to know the number of lines that were updated. So if it's 20 IDs we used in the OR and we got 20 back, then that means all 20 were successfully updated. However, if we send 20 and we just get 15 back, that means just 15 was updated. So we have our counter here that basically we use it to count the total number of updates per statuses. Yeah, so that's what happens here. And then what do I do here? Job IDs, yes. I'll explain what we use the job IDs for. So I also pick the job IDs from here. I make it a list, so I get the job IDs. So then I say for DLL status. So for example, for sent, for delivered, for blocked, X updated. So for sent, maybe 20 updated, for delivered, 10 updated. And you can view this when you access the bulk logger log. Yes. So this is what performs the update for email log. Then we have code here that handles the blacklist. I'll skip this for now. And let me read this. We need to make sure the number of logs updated matches the total number of log processed. This case of 1 second. Okay, this is changed to 200. Since you're saving, okay, I'm using SMS because it's similar logic. Possibility to blah, 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 blah. Okay. So we have total lines processed. So total lines processed, once I read a file, I check the number of lines in the file. The number of lines in the file corresponds to the number of DLLs I have. So if the number of DLLs are equal to the number of updates that was done, then I know it was successful. So if it was 200 lines to be processed and 200 were successful, then I know it was successful and I can delete the file. So this is where I delete the file, right? However, if it's not the same, I split it in the log, will be retried since this was unable to update. Total lines minus total updated. So probably 200 came in, but probably only 199 were unable to update. Yes. Okay, so I wrote a code to handle that. I called it DLL fallback handler. So then if this fails, I hand it over to the code that calls DLL fallback handler. So it's kind of initiated in there, and I will touch on it. We'll touch on this. So we'll touch on add email and then DLL fallback handler. So if all 200 were updated, we delete the file. And then what do we do? It's a class, right? Yes, it's a class. It's a class. Just a minute. So I delete the file, and I think that's it. However, if all 200 were unable to update, I split this into the log, and then I handle it to DLL fallback handler. You will touch that. And then I split into the log, total updated. So if it's 200, 200 of 200 DLL saved, 0 DLLs unable to update duration. So that is this done. So now the next step that happens are, remember, there are three main models we play with: email job, email log, and email job stats. So if I remember correctly, save DLL to DB handles all email log and email job stats. So we just went over the code that handles the email log. So now we need to update the email job stats. So if we go back into the DLL, you could see over here, I am grabbing the job IDs of all, emails we touched. So remember, email log for this 100,000, they all belong to one job, right? And we're able to find, because we're using the external ID here, we are able to get the email job it belongs to. So the email job it belongs to, we come here and then we save email statistics. All what the email statistics does is it runs a summation of the various statistics and then it updates itself. So for example, it goes in here, email log, run the current total pending, the current total sent, the current total rejected, and saves it in itself. Yeah. Any questions on this part? On this current flow? Because I think it's about time I bring it to a close. Yes. So let me answer questions now, and then on our next meeting, we discuss the fallback handler and then how the blacklist also works. So any question on this part? Because I believe with this, you have enough to, start looking at why the DLL is kind of failed. Yeah.
No question from my end.
Okay. Is it that you guys understand it, or Yamekano Charlie? Or you drop government today, or the government enter the system yet?
I think it feels like I'm the one who's going to start the code most often.
Okay.
So kind of me going to ask most of the questions. The rest of the members, I work on the front end and support level. Yeah. So
Okay.
definitely I'm supposed to ask most of the questions. So
Okay.
that's why it's happening like that.
Okay.
I will do that here. When they come attack you. So
all right.
They are just lacking.
Yeah, but Abi, so except Alex, Abi, the rest of you get an idea of what's going on from this image.
Yes, I do.
Oh yeah, VP, I do. And moreover, we have a recorded version of it. So anytime we want to clarify something, we can actually go back to it.
Okay, so I'm gonna drop it off here for today. In the final meeting, I'm gonna discuss how if a file, a DLL fails to update over here, how we are handling it in code. But to just give a short AE, let me not just touch it. Let's leave it today so that it attends syncs to the system. And then I think next week, Tuesday, we handle the blacklisting, how we handle blacklist, and also how we handle this not saving. The other thing I would say is this not saving. I don't know if I have implemented it in the SMS. Let me just quickly confirm. Yeah. Oh, hey. Hold on. Yeah, I don't think this is implemented in the SMS. So maybe that's something that's maybe let's take a look at and see how to handle it. because everyone is something they need the SMS too. Yeah. Okay, so I think I'll bring it to a close over here. Thank you for your time, everyone. I'll stay on for the next 6 minutes. If there are any questions, I'll answer. It doesn't really have to do with this. Maybe there's something that everyone want to ask. If it has to do with this, it would be great. But if there's no question coming up on this, I'm open to any other questions. So yeah.
I think for my end, my question would be more of optimization regards to how I want to scale up. Like
Okay.
for instance, if EcoBank happens to spend like 500K, spend like 500K, how I want to handle kind of traffic with a big PRL design, current design. So I'll ask for any opinion from your side, how I want to scale it up.
For now, yeah, I believe this might work. What I'd say is we need to have a close monitoring of it. By close monitoring, if we are sending out 500K, what we can do is we can first look at what's it called. So whilst it's going out, 500K. Wait, was this done? Campaign was completed, right? Yeah, I think campaign is where we group several reports under one. Campaign. So I believe for that, like just to test that, maybe go do 100, 200, 200 to see under the same campaign. Then we steady up see. Because currently, I think the only way we optimize this we go observe, then see where the choke point is coming from. What I realized was the choke point is not coming from here, where we are sending to Amazon SCS. I know the SCS HPPP. What I realized the choke point was, the reason for this biblical code was one choke point we were encountering a lot. How do I change color? Yeah. If I remember correctly, one choke point was here, right? One of the choke points I saw had to deal with us processing the DLLs. And the second choke point was when we're processing this. That's why I'm currently splitting it into 200 each. We were trying to process this everything at once, and that was an issue. But it's been a while since the test, like there's been a blast ongoing and I was looking at it. But from the last one, I don't remember the number, but it seemed to be going. What usually happens is if there's a time graph of the of what we have as DLRs, it usually is like this. It's a very, very sharp spike, right? Of the initial ones coming in, and then it starts slowly trickling down. So the difficulty part is being able to handle this period, and have everything go on smoothly. So the theme, if you are careful and take a notice of it, you can see I'm trying to limit as much as possible the amounts we are processing at an X moment of time. Because what I realized was happening was, so Nina Ban was saying, however, the processing time, which I'm going to highlight by green, is even though it's coming like this, I'm trying to process it in equal chunks like that. And that's what I'm trying as much as possible to go for. Because initially what was happening was I was trying to process it per data available into a Babibrecia, and I'm trying to do this. And it was leading to headache. was leading to, because what happens is we get one, the DB is quite strong. That's why they'll give it to the DB. DB is quite strong. However, because good, let me point something out before we go. So imagine this 100,000 is going out at the same time. 100,000 is coming in, they are all touching the DB. So this 100,000 email log is also kind of being created at the same time when we are also updating this. There are ways I've gone around this. If I remember correctly, I am not creating this one at a time. I think I'm creating this 500 at a time.
Okay.
Yes, I think initially we were creating this one at a time. So I think I've changed this to creating 500 at a time, so that at least we reduce, because, you know, access to DB is one of the things that slows system down. DB access can be a bottleneck. So I'm reducing this to 500 at a time. So if it's 100,000, instead of doing the DB 100,000 times, I'm probably chatting it maybe 20,000 times or something like that. And yeah, so that's the couple of things that are implemented to kind of optimize it. And yeah, I kind of say, if it's big like that, let's break it down. And then what you have to do is you need to open like 6 or 3 different windows, and then take a look at how the logs are coming in to look at the rate and see how it's clearing. But the last time I saw, it looked okay. It looked okay, yeah. So ideally, it should be stable, but you know the job we do, Charlie. Yeah. Okay. So my time's up. Thank you very much for your time, everyone. And we will meet on Monday. Sorry, Tuesday. Ideally, Tuesday might be the last meeting. If you're able to finish on Tuesday, we will then finish on Friday. So yeah. Okay. Thank you, everyone. Have a great day.
Thank you too. Bye.
Bye.